All right, welcome to the Sunday morning session, math session again. And you guys have been brave enough again to come to this session, uh, sacrificing your sleep. So good job. Now, in case you stop hearing me because of let's say my Bluetooth trips over, just send me chat messages that you stopped hearing me. So don't worry, I will fix it up and come back. In case my Zoom hangs in and my internet trips off, weird things can happen, right? So hang in there. Don't panic. I might restart, reboot my computer, come back, and I'll let you back. All right. All right. So last week we learned something called linear equalities. Equalities are equations. Now, this week, we are going to extend our understanding to learn something called inequalities. And that I shouldn't say inequations, but they're not equations anymore. Now, I hope you're able to see my screen. So what are inequalities? Let's try to understand that first. Now, let me give you a very real life example. There are a few more people coming in. Give me a sec. All right. So let me give you an example. Let's say your teacher tells you to practice maths on a daily basis for time. I call time equals to t equals to 30 minutes. So your teacher tells you to practice maths 30 minutes daily. Now, let's say there's a person, John. I've just picked up his name. Now, John practices 29 minutes. Now, do you think John did obey his teacher? Yes or no in the chat now? Good. No, absolutely. Which means his time, t, was 29, which did not satisfy this t equals to 30 as an equation. It did not satisfy. Now, let's say next day, John studied for 31 minutes. Do you think John obeyed his teacher? No. Simply because teacher asked John to study for only 30 minutes. T equals to 30. So when John had the value of t as 31, and let's see what his teacher said. Teacher said t equals to 30, but John studied 31 minutes. Let's try to plug it in. 31 equals to 30. No, he did not obey. The teacher said exactly 30 minutes, equal to 30 minutes. Now let's change the scenario, right? The scenario now is that John's teacher now says John to study, and I'll change the color of my pen, to study at least 30 minutes. At least 30 minutes. But so in this case, the scenario becomes at least 30 minutes, which means t should be greater than or equal to 30 minutes. Now, if John studies 31 minutes, do you think John has obeyed his teacher? Yes, John has now obeyed his teacher simply because 31 is greater than or equal to 30. So this condition or this rule is now satisfied. So there is a big difference. So there is a big difference between an equation and an inequality, or probably an equality and inequality. Equality talks about being exactly equal. Inequality talks about being either greater or less, greater than equal to or less than equal. So there is greater than, less than, greater than equal to, less than equal to. So if you don't know what this is, so we don't write in algebra greater than equal to. We are lazy and we say, okay, let's pop this in under. So now don't chat, okay? Listen to me. And no, don't go into the nitty-gritties that he obeyed his teacher at least one, he studied exactly 1 minute and so on and so forth, right? Just be. This is a very literal scenario, okay? Just very literal scenario. I'm just trying to make you understand what that's about it. Fine. All right. I mean, I told you to do what? And a question, a quiz for 10 questions. You did not do it. You did not obey me, right? So you better obey me first before you start chatting. Only 18 out of 40 participants attended it. It's a shame, right? So let's stick to the scenario. Don't go into real life. All right. Oh, good. Cool. Coming back to poor John, right? And he's being made to study on a daily basis, 30 minutes. He doesn't like it, right? No one likes studying. I love it. Anyway, coming back, right now, John studied 31 minutes and he satisfied this teacher's inequality. No chatting. I said no chatting. Sharo, you're just disturbing me now. Last warning, you'll be out to the waiting room. All right, I'll start calling names now. Okay? You're disturbing me now. And Kinetic, you as well. There's no need to respond. You guys will go out straight away. All right, cool. Coming back. Now, John studies 32 minutes. Do you think he obeyed his teacher? In the chat now, quick. Guys. Good. Yes, he did. John studied 40 minutes. Did he obey? Yes. John studied 100 minutes. Did he obey? Yes. So, an inequality can have more than one answer, whereas an equality always has one answer. Always remember that. Now, next step. Inequalities, just like equalities, need to maintain a balance, the balance of the rule that they are set against. They are solved exactly like equations or equalities, except there's one exception that we will learn today. I've got a few more people in the waiting. 41 now. All right, cool. So they're solved exactly like equations, except a rule that I will teach you today. So coming back to John, and how do we represent inequalities and equalities? Both can be represented on something called a number line. How many of you have heard about the term number line? Yes, yes, if you've heard about it, right? I'm pretty sure you would have. All right, so let's say when John's teacher told him to study for 30 minutes, if I draw a number line, and number line always has negative infinity and positive infinity on their left and right respectively. And let's say this was 0 here. And let's say this was 10, 20, 30, 40, and so on. John being at t equals to 30 is represented by a dot on the number line, which corresponds to exactly one value, t equals to 30. Whereas when John starts to study more than 30 minutes, that means he can go up till any point from 30 minutes onwards. So what we do is, rather than showing this as a dot, we show this as I don't say dot, a circle, a shaded circle. It's also called a closed circle. So this is also called a closed circle. And when I draw a non-shaded circle, it is called an open circle. Now, when I have to draw John's mathematical effort, I mean, in the sense of time that he's put in, greater than 30 minutes, I just draw like this. So which means from 30 minutes onwards, he studied. And it could be any amount of time that he wants to. So that is the difference between how an equality is shown on a number line in comparison to an inequality being shown on the number line. Now, let's move forward. Let's see how we are going to solve these inequalities. Let's try to solve an equality first before we solve an inequality. And even before that, let's try to write some inequalities. So now hear me out very loud and clear. You need to write me an inequality which says x is greater than 2. Can you write this inequality and give me in the chat, please? And I'm asking you very, very elementary stuff that you've learned in grade 4, 5. Good, simple. But then if I say greater than equal to, how would that change? Good. Simple, not a problem. If I say x is at least 3, how will you write this? At least 3 is as an inequality. I'm just looking at the chat. When I'm saying at least, now tell me, think about this. A lot of you are correct, a lot of you are incorrect. Right? Let's understand the word at least. If there are 5 chocolates in front of you, and I tell you, pick up at least 3. So how many will you pick up at the minimum? If I say pick up at least 3, obviously 3, will pick up 3 onwards. So someone can pick up 3, someone can pick up 4, someone can pick up 5. So at least means a minimum, a minimum. So at least is nothing but at least 3, greater than equal to 3 or more. Yes, Sakita. Yeah, exactly. That's another good uh, English word. 3 or more. Good. If I say x is at most 3, write this down. At most. Hint, it is opposite of at least. All of you, there are 40 odd people here, 43. I need all of you to write it down once. At most. At most means at the max. Maximum. You should not go over 3. So x should be less than. This is what at most and at least mean. Remember that always. It is very, very frequently asked. Now, if I say you x is greater than two, but less than equal to equal to equal to 5. How will you write it? X is greater than 2, but less than equal to 5. How will you write it? Kinetic, you have a hands up. If you have a question, please type in, my dear boy or girl. Sorry, whosoever it is. Your names are tricky. Okay, let's understand this. You're just throwing stuff in the air. X is greater than 2. If I just draw a number line, let's say I draw a number line. This is 0, 1, 2, 3, 4, 5. X needs to be greater than 2, which means, X can be here, but less than equal to 5. So that means that's my boundary. So you will write 2. That's how you write it. You can also write it the other way around if you really want to. So you can write it like this. But that is not a good hygiene. That's That's not how we want to look at it. The smaller numbers are always on the left-hand side because of its nature, and the greater number should always be on the right-hand side. So always write it like that. And this is acceptable, but kind of not. It is confusing. The brain functions in such a way that it is used to seeing smaller quantities on the left, whereas bigger quantities on the right. So you always write it like this. Greater than. So it's only greater than. Or you can slice it dice. You can slice and dice it into two parts. X is greater than 2. All right. X is greater than 2. X is less than equals to 5. X is less than equals to 5. Just combine them. Combine them. 2 and 5 is here. X sits between them in the middle. You have the mouth open towards X between X and 2. So you make sure the mouth is open towards X. And you have a mouth open towards 5. Just make sure that the mouth is open towards 5. It is as simple as that. So whenever you are given a wordy inequality and you have to write it down into numbers and you don't want to do number line, which is fine, just break it down into multiple inequalities and then combine it. Is this making sense? Now, if I say, not sure, can I copy it here? Or I can try. Copy. I can. Can you see this by any chance? X is greater than -3, but less than equals, he's giving you the answers. All right. So X is greater than -3, but less than equal to 1. Can you try this? Can increase, I think, the font. Yeah, I think it's better now. Go for it. X is greater than -3, but less than equal to 1. So what I will do is I'll simply break it down into the first part and I'll say X is greater than -3. X is less than and equals to 1. And I just combine them now and say, okay, which is a smaller number out of the two, -3 or 1? I say -3. So I'll place them at the corners. I'll put my X in the center. And then I say, okay, the mouth is open towards X. Let me open it towards X. And the mouth is open towards 1. That is the representation. Anyone who's not clear with this, this is very, very simple and sweet concept. Everyone's fine, right? Greater than or equal to. Whenever you have to place an equal to sign, just place this small line underneath the greater than or the equal to. That just means greater than equal. All right? All good? Cool. All right. Let's move forward. Now, let's try to solve some inequality. Let's try to solve an equality or an equation. X minus 3 equals to 7. Can you get me the X, please? Quick. All of you. I need 43 answers. Just one from each one of you. And I'm keeping an eye here. Good. So what are we doing? I said last week, you need to maintain the balance. So if it's a positive negative here, you will add 3, add 3, 3, 3 cancels, x becomes 10. Good. Simple, right? Now I say x take away 3 is less than 7. So the idea does not change at all. You will be exactly doing the same thing. You will add 3 on both the sides because you're going to get rid of this 3 to may leave x all alone on the left hand side from my last week's lesson. So my x is less than 10. That's about it. There is absolutely no difference the way an equality or an inequality is solved, at, at least for now. Now, what was my original rule? My original rule was x minus 3 is less than 7. Less than 7. I have got this answer. X is less than 10. Let me test it. Pick up any number which is less than 10 and try to feed this rule. So let us say I pick up x equals to 2 and try to sub it in. Let's substitute 2 equal x is less than 2. X is equals to 2 because I am only allowed to pick up x values less than 10 and try to find whether this rule holds true or not. So 2 take away 3 is less than 7. 2 take away 3 is negative 1 is less than 7. So this is true. So my answer is right. So that means this answer that I found here, and I sort of changed the color of my, this answer that I found here is absolutely right. Let's try to find another value. Pick up another value. Let's say this time I pick up 11. Let's say I pick up 11, but hang on. I'm only supposed to pick up a value which is less than 10. Then why on earth am I picking 11? I'm just trying. Let me just pick up 11 and try to feed this in and see whether I still get, whether my rule is still true or not. So I say from here, I say 11 take away 3 is less than 7. 8 is less than 7. False. Which means the value that the answer that I found, x should be less than 10, is the right answer. The moment I've picked up any value of x greater than 10, my rule fails. It becomes false. So therefore, it is exactly right. Let's go and try a few more and see where we land. All right. I'm giving it to you and you're going to solve it. Just solve the way the equalities are being solved, right? D over 4 take away 3 is greater than equals to negative 11. Go for it, please. And tell me what is the answer. Even if you don't, just solve it just like the way you're solving an equality, an equation, and you'll land at the right spot. Okay, Nirvi says greater than negative 32. All right. All right. Kinetic says greater than equal to negative 32. Give me answers, guys. Give me answers. More. 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 There are only few that I think a lot of you have struggled to solve this. It's not 36. It's not 36, Karan. It's not negative 36. It's not 32 rhythm. All right, let's try and I'm explaining. Okay, let's go step by step, right? A lot of you are correct, a lot of you are incorrect. I don't think, no, Shadow, it's not 8, negative 8. All right, let's try to understand this. Forget, let this be an equality, if that's confusing you, for example. Tell me, let's go step by step. What number would you like to get rid of first? The goal is I need to leave this poor D all alone on the left-hand side here. Which number should we get rid of first? Okay, let's get rid of the 3, negative 3. So I'll say D over 4 minus 3. I'll just add 3. Always place the brackets, add 3. Open the brackets up. 3, 3 gone. And you're left with D over 4 equals to negative 8. Now, which is the number that I need to get rid of in order to leave my poor D all alone? 4. Good. So, and this 4 is being dividing D. So I have to put a bracket and I have to multiply it. Put a bracket, please. Always don't mess it up. Bracket makes it very simple. Open the brackets up. 4, 4 gone. D is negative 32. Now, nothing on earth changes, right? My original was greater than equal to, greater than equal to, greater than equal to, greater than equal to, greater than equal to. That's about it. Solved. What I did was solved with an equality, swapped the signs. I mean, I then just replaced it with the original inequalities. Is this clear, everyone? Very simple. If you understand the way this is being done, you cannot go wrong. And the most important thing that I keep telling you, and I was telling you last week as well, is brackets are very important. Brackets are very important. If you don't place the brackets right, chances of going wrong are 99%. All right. Let's try maybe one more very similar. Let me just, pull out something from my hat again. All right, let's try this. All right, now x over 2 take away 5 is less than equals to 3. Go for it. Take your time. There's no rush to the finish line, okay? I'm waiting for majority of you to answer this, if not all. I'll still do it. Don't worry if you're not able to. It's not equals to, guys. I mean, place the exact sign back into the stuff, right? Don't forget Taha. I mean, pop the stuff, pop the sign back, inequality sign back. Not and rhythm. You forgot the equal to sign. Greater than equal to. I mean, it could be messy. Now, all right, I'll quickly do it. I'll quickly do it. Yes, x is less than 16 is the right answer. Okay, so what do? I will get rid of this 5 first. Now I'm not going to, put an equality first and replace it. Let's pick this up as it is, all right? X minus 2, x over 2, and I'll say, okay, plus 5 here, plus 5. Always bracket, always. Put the brackets, right? Even if it's single number. Open the brackets. See, when you get used to it, then you can remove, taking brackets off if you really want to save time. But, you can put the brackets in your head. But if you're working it out and showing you're working out to someone, brackets is hygiene. Take this off. This becomes x over 2 less than 8. And I say, okay, times 2, 2, here, open the brackets up. And eventually I get 2 gone. X is 16. Wonderful. That's what it is. Everyone, is this clear now? Absolutely. Now we're going to take the next and the final turn from here. All right, cool. Everyone's fine, right? Yes. Write a yes. All of you. I need to see a yes. Yeah, cool. All right, good. Next bit. Now let's change stuff. Let's understand a little difference in way the inequalities are dealt with. I've got people joining in. Strange, right? Even after 40 minutes. All right, that's fine. Every drop of knowledge is important. All right, cool. Now, let us say I have negative 2x is equals to 8. Give me x, quick. Give me x, quick. Everyone, on your toes, give me x. We've got like what? 44 plus here. 44. Not x plus 4. Give me x. All right, negative 4. Good job. X is negative 4. Now, give me x, quick. Give me x again. In the form of inequality. Give me x in the form of inequality. Write x equals less than, greater than, whatever you can pop that in. Give me x. Okay. For laptop, just say greater than and then an equal sign. It is absolutely fine. You don't need to say greater than. I mean, how? Yeah. Yeah, just do exactly what Shadow's just done. All right, cool. Now, hang on. All of you are incorrect. All of you are incorrect. All right, cool. Let's try to deal with this. Right. You told me that x is greater than equals to minus 4. Okay, I take it as what you've given me. This is, and hear me out very loud and clear, okay? This, without any distraction, this is the original rule. that I have to satisfy. Shadow, stop doing it. This is the rule that I have to follow. Now, this is the answer that you've given me. X should be greater than -4, greater than or equal to -4. Give me, let's pick up a number, a value of X which is greater than or equal to -4. Let me see. Give me a number. Give me a number, a value of X which is greater than -4. Give me a value. Kartiki said -1. All right, let's try with -1. Let's drop it in here. -2, -1 should be greater than 8. -2 times -1 is 2. 2 is greater than 8. Is this true or false? This is false. So that means this answer is incorrect. Now, what do we do? What do we do? Very, very simple. And that is an exception that you need to learn. That's the exception rule, especially for inequalities. And the exception rule is when you have a negative number, hear me out, just stop teaching me online. Stop teaching me, all right? Hear what I'm saying. When you have a negative number, which is either multiplying or dividing your variable, what you need to do is, the result is, when you are making them, whenever you're doing the inverse operation, when you're trying to get rid of them, always flip the sign. Always flip the sign. What it essentially means is, let's try to do it. So you had -2x is greater than 8. This -2 is actually multiplying x. And I told you, whenever you are multiplying, whenever you have something which is a multiply with the variable, when you are getting rid of it, so which means that you are trying to divide on both the sides, that is what you're going to do. You're trying to divide. You need to change the sign. It's only when you're multiplying or dividing. So finally, what you will get is x is less than equals to negative. Is this clear, everyone? Yes or no on the chat now. We've got 15 minutes. We'll try this a bit. And I want you to, crack this, right? I'll take an example of a division as well, right? Just in case. I'll take an example of division. So let's say, let's find something. To make something. All right. So let's say I have d over -4 is less than 5. So what I'm going to do is I'm going to get rid of this -4 by multiplying negative. Now this -4 is dividing. So the rule, if I scroll up, was division or multiplication needs to flip. And I flip the sign. So finally, 4 gone, d is greater than -20. Is this clear? All right, now I'm going to mix it up again. right? I'm going to mix one more up and then I will throw at you, okay? And then we'll do it together. No, there's no kinda, yes or no. The answer is either yes or no. There is nothing called kinda in life, right? Let's be black or white. All right, let's do one. And I'm going to mix a few things up, right? I'll mix a few operators up and then we'll see how you go. Now I'm saying that, let's make things up. I say negative 2x minus 2 is greater than, let's say I say, make stuff up, 6. Now, I don't want you to do it now. I'm doing it, and then I will throw it at you. I'm going to do one more. You just give me the answer when I'm chatting, okay? When I'm asking you, just throw it on the chat. Tell me, probably let's, maybe 4. Sorry, I'm just doing few things in my head. All right. Which is the first number that I want to get rid of? Quick, we've got 10 minutes. I need you to quick. I need you to be really quick on this. Negative 4. Cool. Now, this negative 4, which is the operation involved here? Multiplication, division, subtraction, addition. Which operation is this that this 4 is hanging around with on the left-hand side? It is subtraction, right? It is not multiplication or division. So what I will do is I will say negative 2x, take away, and I'll say positive, positive. I did not change the sign here simply because this negative is subtraction. So I open the brackets up, this is gone. What I'm left is with this. That's what I'm left. Now, what number do I need to get rid of? Quick. All of you, quick. Negative 2. And what this negative 2 is doing to the x, it is multiplying x this time. Now my exception rule kicks in. When I divide this with negative 2 on both the sides, I will flip the sign. So my x is less than. Everyone, is this clear? Yes or no? And I'm now going to give you, things to work on, and we go from there, right? I've simplified it to the basic level, right, to make you understand this, so that you don't go wrong in future. All right, let's do one, right? Let's try one. Take your time. There's no rush. All right. Let's see how you go. 5 take away negative 2x greater than 3. Go for it. Starting now. We've got 8 minutes. We'll do a few questions and I'll call it a day then. It is 5 take away 2x. There is no equal to sign. It is either it is greater than sign. So anyone who's dropped a equal to sign is incorrect. The sign needs to be exactly matched, right? Equal to, if it is not mentioned, should not be there in your answer. Not everyone solved it. I'm waiting. Okay, Khyati, I'll do it. Don't worry. Arav, looks like you haven't got it as well. Let's do it. Let's do it together. All right, x is less than 1 is the right answer. Let's quickly do it. Okay, tell me, people who have not understood this, which number do I need to get rid of first? Of x, 5 or -2? I can get rid of either of the two numbers, but which is an easier one for me to get rid of first? Any is the right answer, but easier one to get rid of first. 5. Good. 5 is adding. There's an addition. Basically, if there's nothing written in front of a number, it is a positive. So what I need to do is I'll place the bracket and I will subtract. Right? That is what I'm going to do. So this becomes -2x is not -8. Sorry about my bad. This is 3 is 2. -2. And now, which number do I need to get rid of? -2. It is multiplying. So I divide. And when I'm dividing, I flip the sign. Gone. X is, and I gone, this is 1. Did you understand that? All of you, flip it. And that's about it. All of you who said, no, we did not get it, did you get it now? Good job. Good job. All right. Let's do. I mean, see, I tell you, life is not that easy. No, if I would have written it like this, probably you would have picked it up quickly because, oh, you're used to seeing these numbers being added or subtracted towards the right hand side. I just changed it. So anything can happen, right? The concept still remains the same. All right. So don't get bogged down by, if the numbers are being, moved in here and there. So, I mean, for example, very basic thing is if I say um, 3 minus 2, you will say 1. Good. But if I say -2 plus 3, it is still 1. What I've done is I just swapped the numbers. That's it. You getting my point? I'm just swapping the numbers in. That's about it. All right. Shall I throw another one at you? Hmm? Let's try this one. Uh, just thinking, what should we try now? Okay, let's try a brackety stuff. See how you go. Maybe the last question of the day, right? Today. I mean, I can keep going for another 10 hours practicing this. There's so many variations, but the ground rule still remains the same across the board. -3 outside, a plus 5 inside, greater than 9. Can you solve it? Go for it, solve it. Open the brackets up first, Karan. That's about it. Open the brackets up and then this becomes a cakewalk. Abir, I need to see the sign, not a comma. The answer is right, Abir. You need to pick up the sign as well. That's it. Retype. Okay, Arav, we'll do one more. Don't worry. We'll do it. All right, cool. Let's do this and see where we land. Let's open the brackets up. So this becomes, and I think Karan or Arav, someone, was confused. So be with me, okay? Negative 3a minus, now this negative 3 is going to be multiplied across when I open up the distributive law of algebra. Greater than 9. I think someone wrote this. Now I'm going to get rid of 15, negative 15 first. And I will always place the brackets. And I don't forget my brackets. My brackets are very. Open the brackets up. I become 15 plus 9, or 9 plus 15. 15, 15 gone. So 24. Now I need to get rid of the 3, negative 3, and now this negative 3 is multiplying. There's a multiply. So I'll say, okay, let me divide this. Let me divide this. But hang on, I now need to flip the sign, my exception rule. So eventually, my A is less than. Cool. 10 a.m. And with that question, I end my lesson for the day. Thank you very much for attending. Again, as I say, lovely morning. And I love seeing you every Sunday morning and interacting with you. This is my favorite hour of the week, right? And I hope for you as well, it is the case. And make sure that you are doing your homework. I mean, a small assignment that I do, and keep practicing. And God bless. Enjoy the lovely sunshine of Sunday. Have a great, weekend ahead.